So hello everyone. Today we see some problems on salt hydrolysis. Okay. So already we know the types of salts and how to identify the types of salts and how to identify the nature of aqueous solutions of the salts. So based on that we have some formulas and we do some calculations. See the first one. So the hydrolysis constant of mx salt. So the salt is given as mx. Actually here Kb is given as MOH, means here M is obtained from base, its Kb is given, and in the salt X is obtained from a weak acid HX. Kb is given, Ka is given, means it's a weak acid and weak base. So here we can say the salt Mx. So Mx is a salt of a base MOH, acid HX. We have to identify it. So which K is given, Kb is given, so means we can write that the salt Mx is a weak acid, weak base salt. We have to identify what we have to calculate a hydrolysis constant for it. So we know the formula hydrolysis constant Kh equals Kw by Ka into Kb. We know this is as a formula. So we have to find out the Kh. What is Kw? So Kw is also constant for water. That is 1.0 into 10 power minus 14 moles square per liter square. Okay. Next. What is a K? K is given how much? K means acid dissociation constant of weak acid. That is 5 into 10 power minus 7. So next Kb, weak base dissociation constant minus 5. So substituting all these in equation 1, the hydrolysis constant. Here what we have to calculate? Kh. This is called hydrolysis constant. Okay. So what is the Ka? So this becomes 10. Already 10 by minus 10 is minus 12. Okay. Become minus 11 and become 10 power. So 10 power minus 3. So the Kh value is 10 power minus 3. It has no units here. Okay, so the here hydrolysis constant of for weak acid weak base is 10 power minus 3. Actually in the options given it is 0.001. Okay, see the next problem. See the second one. Find the hydrolysis constant Kh of a salt of sodium hydroxide and a weak base, sorry, a weak acid. It is not mentioned, just it is given as a HX. If the K of HX is 2 into 10 power minus 6 is how much? Means in the same problem here we have to calculate the equilibrium sorry. Here we have to calculate the hydrolysis constant KH of a salt. So what is the which type of salt? The salt is formed by sodium hydroxide and a weak acid. So K is given means nothing but it's a weak acid. So therefore before writing the formula we have to recognize which type of salt is there. Means the salt is obtained from uh, which acid and which base. So here it is a strong base, weak acid. So the salt is so weak acid, strong base, salt. So we know the formula for weak acid, strong base for KH. For them KH equal KW by K. Okay. So always generally in the denominator the weaker term is already there. So weak acid unte, so actually ఏది weak part ఉంటే దాన్ని మనం hydrolysis లో ఇన్వాల్వ్ చేస్తాం. Actually the weak part, the salt, the weak part only undergoes hydrolysis. Weak acid, weak base అయితే రెండు both undergoes hydrolysis. ఇక్కడ strong acid, strong base, weak acid, only weak acid undergoes the hydrolysis. Okay. So what is the total nature of the solution? The strong base carbon nature will be base. So 1 into 10 power minus 14. What is the Ka? 10 power minus 6. Just we have to recognize which type of salt. Okay. Make it as 1.1 by 2. So 10 power minus 8. The option is 10 power minus 9. Okay. See, some more problems are there. So given that Ha is a weak acid with Ka is equal to 10 to the power of minus 4 and BOH is a weak base having Kb equal to, so directly given 10 power minus 5. If Ba is the salt formed by them, then in the aqueous solution in the aqueous solution of Ba salt, so here Ba salt, actually there is some options here given. We have to compare the answers with options. So the options are given. H plus is greater than 7, sorry not 7, so in book it is given 7 actually, but the concentration not like 7. Next option B is given pH is less than 7. The C is given hydrolysis constant KH equal to 10 power minus 5. So here all. So we have to identify now which is the correct one. How to calculate means we know that actually there is two concepts are present. So one is so ఇక్కడ అన్ని ఆప్షన్స్ మనం చెక్ చేయాలంటే నేచర్ ఆఫ్ సొల్యూషన్ తెలియాలి. అంటే H plus concentration, pH value. If H plus concentration is greater than 10 power minus 7, so automatically pH will be less than 7. అంటే ఫస్ట్ టూ ఆప్షన్స్ చెక్ చేయాలంటే ఇట్స్ ఏ థియరిటికల్ బేస్డ్, అంటే which ఇక్కడ సాల్ట్ ఏ టైప్ ఆఫ్ సాల్ట్ డిజాల్వ్ అయితే వాటర్లో రియాక్ట్ అవుతాయి, హైడ్రాలిసిస్ రియాక్షన్ అవుతాయి, వాట్ విల్ బి ది నేచర్ అది ఐడెంటిఫై చేయాలి. నెక్స్ట్ ఫర్ KH we have to do the calculation, means it is a combination of two concepts of salt hydrolysis only. So it is a weak acid weak base. So weak acid weak base, it's very important. It is given as a salt of weak acid weak base. So జనరల్గా మనకి డైరెక్ట్గా ఐడెంటిఫై చేయడానికి సింపుల్ హ్యావ్ ఎ టెక్నిక్ దట్ బోత్ స్ట్రాంగ్ అయితే డైరెక్ట్లీ వీ కెన్ సే ఇట్స్ ఎ న్యూట్రల్ వన్. ఇఫ్ స్ట్రాంగ్ యాసిడ్ వీక్ బేస్ అయితే ద నేచర్ విల్ బి యాసిడిక్. ఇఫ్ వీక్ యాసిడ్ స్ట్రాంగ్ బేస్ సాల్ట్ అయితే ద నేచర్ విల్ బి బేసిక్. అయితే ఇఫ్ బోత్ ఆర్ వీక్ అయినప్పుడు నియర్లీ న్యూట్రల్ అండ్ నాట్ ఎగ్జాక్ట్ న్యూట్రల్. It may be some acidic, it may be some base, it depends on the strength of the acids and bases in that weak acids and bases. రెండు స్ట్రాంగ్ అయినప్పుడు అయితే ప్రాబ్లం లేదు, అది వి డిస్కస్డ్ ఇన్ ద ఎర్లియర్ సెషన్. బట్ రెండు వీక్ అయినప్పుడు మాత్రం ఆ రెండిట్లో మేబీ ఎగ్జాక్ట్లీ సేమ్ ఈక్వల్ కాకుండా డిగ్రీ ఆఫ్ డిసోసియేషన్ కొంచెం డిఫరెన్స్ ఉండొచ్చు. హౌ టు ఫైండ్ అవుట్ దట్ యాసిడ్ స్ట్రెంగ్త్ అంటే విత్ ద హెల్ప్ ఆఫ్ Ka వాల్యూ. సో యాసిడ్ స్ట్రెంగ్త్ ఆర్ బేసిక్ స్ట్రెంగ్త్ హ్యావ్ ఎ రిలేషన్ దట్ acidic strength directly proportional to Ka, or strength of base nothing but we can write basic strength. Basic strength directly proportional to Kv. Actually there is a root values are also there, but for comparison we are writing like this. Means if Ka value highest, acidic strength will be more. Kv value highest, basic strength will be more. Here compare the K and Ka values. The Ka value is given 10 power minus 4. Kb value is given 10 power minus 5. So which is higher one? So Ka will be greater than Kb. So here we can write given that Ka is equal to 10 power minus 4 and Kb is equal to 10 power minus 5. So therefore, here we can write Ka is greater than Kb. అంటే రెండు వీక్, యాసిడ్ వీకే బేస్ వీకే, బట్ రెండు కంపేర్ చేస్తే ఇఫ్ యూ కంపేర్ ద యాసిడ్ అండ్ బేస్, యాసిడ్ ఈజ్ సమ్ వాట్ స్ట్రాంగర్ దాన్ బేస్. Therefore we can write acid is acid is stronger than base. So what will be the nature? Therefore the nature will be acidic. So here we can write a point total final solution manaku strong acid undi kabatti acidic nature vastadi. So therefore the nature of aqueous solution of salt is acidic. So acidic covered automatically we can write so acidic. What is the rules for acidic? So acidic means the concentration of H plus is greater than -7. So greater than -7, so automatically pH will be less than 7. Okay, means option A is correct. Option B also correct. So option A, option B correct, and then automatically we can write the options all is the answer. But we do how it is, because it is based on the calculation. So now we got that A is correct, B is correct. Now we calculate. So actually, so A and B two options correct and so nothing but option D all untadi. But we do the calculation. So actually it is given, it is the salt of weak acid weak base. Already we done it, this calculation, this type of problem, that is KH is equal KW by K into KV. Kw means exact value 1.0 minus 14 at 25 degrees Celsius. So minus 4 is given. It is given 10 power minus 5. So 10 power minus 14, 9. So kh equal to 10 to the power of minus 5. Okay. Means option C is also correct. So therefore answer is D. All options are given in the problem are correct. Okay. So in these problems we have to just recognize which type of salt, which formula we have to use. That's it. Very simple problems. Let's see one more problem. KH of salt obtained from strong acid, weak base, strong acid and weak base is, it is given 2 into 10 power minus 5. The Kb of the weak base is how much? So what is the which type of salt? Strong acid, weak base. It is a salt of a strong acid, weak base given. So we know the formula. So there is a Kw by which is weaker one. We write that only. That is a Kb. If both are weak, we return Ka into Kb. If here only weak base is there, actually here we have to find out Kb. We have to find the Kb. Kh is given how much? So substituting them in equation 1, actually we need to get Kb. So Kb equal, you can write Kw by Kh. Therefore Kb equal to 1.0 into 10 to the minus 14. One by 2 I am doing, as I am writing at 0.5, so plus 5 becomes 9. So 5 into 10 power minus 10 is the answer. Okay. See one more. The problem is calculate the hydrolysis constant of salt of weak acid. So given Ka is equal to 2 into 10 power minus 4. Sorry, not minus 4. It is minus 6. And of a weak base. So given that Kb is equal to 5 into 10 power minus 7. So I have to find the hydrolysis constant. So already this type of problem done today. So it is a salt of which type? It is a salt of a weak acid and weak base. The KH equals KW by this is 10 already minus 13 is there 13. So 10. That 10 power minus 2, that is given 0.01. Okay. I think we have one more problem on it. See one more. MX is the salt of a weak base and strong acid. Then which of the following is correct? So actually we have to compare the answer with options. So there is some relations are given. There is a KH into K. 10 power minus 14. Option B. So KH into KB equal to 10 power minus 14. K into KH equal to 10 power minus 14. Option D all. So it's very simple. With the help of direct formula, it is given weak base strong acid. So therefore we can write the hydrolysis constant KH, weak base. So KW weak base we have to write KB. Just we have to find the relation. So just substitute the KH. So KW value we know that 10 power minus 14. So the problem is also in the problem it is also given exactly at 25 degrees Celsius. I was not written this because all problems we are doing at room temperature only. Because we know the KW value only at 25 degrees Celsius. And that's 14 by KB. So compare the relation. So the K term is not at all present. K is wrong options. So remaining one only the correct. KH equal to KB. It can be written as KH into KB equal to 10 power minus 14. Okay. So these are the some one type of problems based on salt hydrolysis. There is also pH problems are also present on the salt hydrolysis. Today we see the formulas to calculate the pH of the salt solutions. Okay, first we read the formulas. Okay, these are the main formulas used for the calculation of pH. I give you explanation. So if you know the type of salt, weak acid, strong base. We know that weak acid, strong base having KH equal KW by K. So with the help of this KH value overall derivation, we will get the direct pH. Actually, we are not giving the derivation. So nothing is used for derivation here. Okay. So here pH we get half into pKw plus pKa plus log C. C is the concentration of the solution. Okay. Next, if it is a strong acid weak base, we know the KH equal Kw by base is V, that is Kb. Then we can write the pH equal half pKw minus pKb minus log C. Next, so for the salt of weak acid weak base on hydrolysis, it's KH equal to Kw, here both are weak, you can write Ka into Kb. So the pH of that type of solutions is half into pKa plus pKw minus pKb. Okay. Next, last one, strong is strong acid, strong base. So there is no relation between, because so there is no Ka, there is no Kb for strong acids and strong bases. So already they are neutral. Stronger means both will be stronger, both undergoes nearly 100% degree of dissociation. So that's why we can write exactly the neutralization takes place. That's why we can write it as pH equals 7. So there's some more problems are there. We'll see in the next class about this. But you must be perfect in these formulas. Okay.